Now, this is a very beautiful problem. I have seen many people, giving different answers for this. Even I have a different answer for this. My answer would be different than the majority answer, and you have to tell me if there is any mistake in that. So, they are asking if this value, where p and q are natural numbers, positive. They are asking whether this thing is positive or not. And the question also, I have the option, the question can be answered even without using any of the statement. Even this option is available. So I want you guys to pause the video and try to do it yourself. So that's the question. I will show you the answer. So this is a solution. I'm going back to the question. Okay. Now I'm going to show you. So if I do this thing, they are looking for p plus q whole square minus 4pq, where p and q are natural numbers. If I expand this value, p plus q whole square is p square plus 2pq plus q square minus 4pq. If you do this thing, this part will get 2pq minus 4pq will become minus 2pq. So p square minus 2pq plus q square. And frankly, this is actually in the form p minus q whole square or q minus p whole square. Anything. The thing is that we just found out p plus q whole square minus 4pq. I can simply replace that value with this. And interestingly, if this is the value, you will feel like this is always positive, because whenever you take, see, p and q are natural numbers. Whenever you take the square of any natural, any integer also, even subtraction integer can come, right? You are going to get a positive number. Okay, so you will feel like this is always positive, and this can be answered by even by without using all the statement. But there is one case which you are missing, and that case is that, imagine if I'm not using any of the, p and q are natural numbers. Now imagine if I'm not using any of the statement, then there can also become a case. They never say that p and q are distinct, where p and q are natural numbers. That's all they're saying. They never say that they are distinct. That basically means that p and q might be equal also. So what if p and q are different, then it is fine. If p is 3 and q is 2, I'm going to get 1 square, that is positive. Or if p is 3 and q is 5, I'm going to get minus 2 whole square, that is also positive. But the problem is that if p and q are equal, if both are 3, then I am going to get 0 square, which is 0. The problem with 0 is that it is neither positive nor negative. So if the question is asking you if p and q, if this value is positive, if you are not using any of the statement, then the answer would be, it might be either positive or 0. Or that basically means it can be positive or it cannot be positive. 0 is not positive nor it is negative. So if you don't use any statement, the answer would be, you cannot answer this problem, because there is two cases, 0 or positive, or non-positive or positive. Therefore, you actually have to use the statement. Imagine if I'm using statement 1, p is less than q. Okay. The moment p is less than q, they are basically telling you that they are not equal. If p is less than q, whatever the value is, okay, even if p is less than q, q can be like 3 and p can be like 2.9999, even then this is going to be p minus q, like minus 0.00001. Square anyway is going to be positive. So using statement 1, I can answer. Similarly, statement 2, p is greater than q, p is greater than q. Even that case gives the same scenario. Why? If p is greater than q, that is also saying that p is not equal to q. Then also you are going to get some positive value. So if I get any one of the statement, I can answer the problem. It is positive. So if you can see such a option, the question can be answered by using either statements alone. You can answer the question by using any of the statements alone. So I would answer this as B. The reason is that they never say that P and Q are distinct. So the possibility of 0 can also come. Therefore, my answer is option D. It is not D, it is B. Sorry, my answer is B and it is not D. Thank you guys.